do not have any homework to check for you, but you did have homework. It's not due yet today, right? You get 2 business days. So you right now should be filling out your plan book, filling out your table of contents, checking your homework with your partner. I had some people abusing when I was putting just the answers up on the board, so I'm not going to do that. If you have a question about a homework problem, please ask and we will go over it. This 5 minutes is yours, unless you want me to solve some problems for you, and then I will spend hours, I guess. But yeah, you got 4.5 still remaining. Make it worthwhile. By the way, this is going to be important on your homework for quartile. Make sure you know what that means. It means a section, a quartile is a section when it's broken up into fourths. So a quartile is essentially a fourth.
So it's like on the grid.
It doesn't have to be. Yes, kind of, but it doesn't have to be. So quartiles take anything, like even numbers, break them into 4 groups.
Okay, so you could put 4 tiles in a room and say one of them is a quartile?
Yes, but those would be very large tiles. Extremely large format tiles. Now, I will also say, if you look up quartile on the back of your book, that will be extremely helpful because it will show you a histogram probably. Okay. Because that means it's probably going to be important.
Good morning. Please pardon the interruption. If I could please have Jeremiah Smith to the office for just a moment. Also, any Phoenix students that have Worthing Way as their neighborhood middle school. We have tryout packets for the Worthing Way musical auditions that are coming up. And any Phoenix students interested in our Phoenix evening canteen payments are due by today. Thank you.
I got really messed up. I can't do it. I got the order completely mixed up.
For what? The diamonds?
No.
Oh, that's what. Don't worry about that. That's fine. I am a creative problem solver like you, so that's all good. I'm down with that. What? He didn't want to use a whole other sheet, so he used like a quarter sheet from graph paper and just taped it in. That's a good idea. You still got 2 minutes. You can be working on homework right now. Quartile says it right there. It is a section when things are broken up into fourths. So a quartile is 1 chunk. It's essentially a fourth. So if you want to give me your attention for a minute, we've still got 2 minutes left, but let's talk about a quartile. If I have a set of something, and I put it in order, say I have numbers 1, 2, 5, 8, 9, 17, 21, 25, 28, 30. And this gets kind of hard, actually. I'll show you guys why. It can get kind of hard. Up here, I've written 10 numbers. So if I break this up in half, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, okay. So here's my half split. But now to break it up into fourths, well, I have 5 over here and 5 over there. To cut this in half, I'd be straight through the 5. So now the 5 is like gone. It's not gone, but it's not in either quartile. So it is now like a split point, but my first, and your homework shouldn't be this hard, it should have something divisible by 4. 10 is not divisible by 4, so I wanted to show you a more difficult situation. Your first quartile is now right here. Your second quartile is now right here. Again, the 25 does the same thing. It becomes your split point, and this is quartile 3, and this is quartile 4. So quartile is just put it in order, break it up into fourths. So if you have questions on that homework problem, let's talk about it tomorrow. Yes. Mm-hmm. Yeah. Yeah. Okay. Yeah.
So like, if you have say x plus x times like for example 4, simplifying the x is that
If it was multiplication, it stays multiplication. I would need to see it. You need to show me how it's written in the beginning. Is anything in parentheses or anything like that?
no, but like
So
let's say
this
I'm common.
is 4x. Right? Because those are connected. Those are attached. So what you really have is 4x.
I just mean
Division?
what should you
So the order of operations, that has to happen first. So that is a fourth of x. Let's talk about this later. Can we talk about it like later or something? Okay, can we talk about that later? I can't change it right now. Sorry, I got screens up and everything. Alright, we gotta dive in. Oliver, what's up? Sweet. Which one? I'm guessing in 324. Oh yeah, DJ. Sorry, 323. DJ Hudcat picked up the DJ lights last night. There'll be a canteen like you've never seen. It will not get canceled. You said 397? Ah, and this is the one that I told you guys was going to be tough, and I really hope that you please try. So this is like what we talked about at the very end of class yesterday with the different types of graphs that are not all straight lines. This does not come out to be a straight line. When you square a negative number, what happens? It becomes positive. So when I square negative 2, what do I get? 4. So then I do 4 minus 4. Okay, well this is 0. Negative 1 squared, 1. 4 minus 1, 3. 0, oh, that's just 0. 4 minus 0, okay, 4. This is the same as when I had negative 1. So 3 again. This is the same as because when I square it, it acts the same, and this becomes 0. And this is the same. You should end up with a graph. I'm not going to show you exactly where it is, but that comes up and then goes back down. It is going to be a parabola, if you want a $5 word on there. Parabola. Parabola. Wow. Don't say curvy, because that makes it sound like you could, like, squiggle. We're just talking about homework from last night. So, guys, you did 97. The graph looks funky. It ends up looking like, not that it's in this location, but it looks like that. It would actually be, it's going to look like that almost. It's going to look almost exactly like that, actually. Hey, so I'll give you more than I really wanted to. This point right here, x of 0, y of 4. Yeah, it is the y-intercept. I just so happen to draw this like very well, even though I did it over here. Right here, x of 2, y of 0. Right here, x of negative 2, y of 0. So those are your nice reference points to make sure if your graph is correct. And then you can do, my other ones might be off, my negative 1, positive 3. Woo! Okay, this one's slightly off. Over here, that got a little goofy, but that one's really good. Yeah, I lucked out. We're doing parabolas in math too, so I'm used to drawing parabolas. It's like when somebody draws a perfect circle and you're like, whoa! No, they're just used to it. They've just practiced it.
Wait, what is the y-intercept even important for? Is it just there?
What amount you have when your input is nothing.
Isn't that nothing?
When your input is nothing, how much do you have? Yeah, we can do.
Is it the formula for a semicircle?
Don't worry about that. This is not a semicircle. Okay, let's be really clear about that. Okay, which one? Do you want to actually talk about it?
Today's.
Oh, well then no. You're not allowed to ask about homework we haven't covered the lesson on. I've talked about this with multiple people. We haven't done the lesson. You can't ask questions. Alright, today's lesson. We are doing this whole thing, no skipping around, if at all possible. Please make sure that we're with us. I can't ever tell if you guys are engaged or not, but I feel like you're going to miss some pieces of conversations that might be beneficial to you. And I'm not just talking to individual people. There are some of you who are really good at not paying attention, like sneaky, and realize as we get deeper and deeper, even though I'm having a conversation, answering a question for one person, you want to listen to that because that information is beneficial to you. So please don't say like, oh, he's answering Bouvendir's question. I cannot pay attention. You need to be paying attention because it is knowledge that you need.
If they're really good at being sneaky, how do you know that they're being sneaky?
Because I'm really good at being sneaky too. I was the sneaky kid.
Wow.
You want to know a really good sneaky strategy?
No.
Sit in the front. They don't expect it. Sit in the front. They don't, like the good students sit in the front, right? If you sit in the front, they don't expect it. All right, let's dive in. All right, so we have talked a decent amount about the distributive property. Can anyone wrap up like what the distributive property is, why we use it? Like, I mean, you can reference our situations here, like in 108. Alex, what's up?
It makes math easier.
Okay, why?
Well, you take take the example in 108.
Okay.
Like what you would do was you take the number on the outside of the parentheses and then multiply it by the number inside of the parentheses.
Okay, so do I just like
It's not just
Yeah, you
numbers.
just kind of
It's also
know.
very.
What you do is multiply it individually, and then after you do that, then it's basically then you add. Well, basically you use the symbol inside the parentheses. Like if it's multiplying it inside it, then you multiply them. But since this one is addition, you would add the answer of the.
Yep. So the only caution I'll tell you is I agree with everything you said, except if this is not positive, you got to be careful because then this symbol might change. So exactly what Alex said. Please write this down. Join me. 108. We draw the arrows to make sure that we do break up the multiplication. Not break up and like, I don't love you anymore, but split it so that it goes to each of them. Because this is like saying, I've got 3 groups of x and 4. I've got x and 4 here, I've got x and 4 here, I've got x and 4 here. So I could say I've got x and x and x, or I've got 3 groups with x's in it. I could say I've got 4 and 4 and 4, or I could say I've got 3 times 4, which then I can just say 3 times x is 3x, 3 times 4 is
12.
Can I combine those?
Yeah, 4.
I add those, I just get 15x, right?
No.
Why? Who can tell me why, Will?
Because 3x is saying that there are 3 x's, and then the 12 is not saying there are 12 x's. It goes to be 12x.
So those are 12 what?
Those are just 12 units.
Just 12 unit tiles, right? The 1 tiles?
Those are 3 x's.
So these are not, what do we call it? Blank, blank. Ooh, not common terms. Sky? Like terms. These are not like terms. Right? So, do B, C, and D on your own. B, C, and D. Distribute, and then simplify. Combine what you can. Not sure. I am going to capture this, and then if I have a volunteer that would like to come and do B. So I'm going to drag this up to the TVs, and if anybody would like to come up and solve these, we'll write them out one at a time. Bouvendir, you're going to do B? Come on. Anyone want to do C? You want to do C?
Yeah.
Now you do C. So show your work. If you're going to come to the board, you got to show your work. No skipping steps at the board. So you need to think about what result do I get after I multiply. So each arrow that Bouvendier is drawing, I'm going to kind of narrate for Bouvendier. Each arrow he's drawing is a multiplication, right? So we have 4 times 2x. What do we get? Then we have 4 times a minus 1 or a negative 1. Or, and guys, this is the problem. This is where things get difficult. In my lower level classes, not accelerated, I don't tell them all of the options, right? Because we don't want to confuse people. You guys are upper level, right? I'm trying to like go a bit deeper with you. This can be thought of a lot of different ways. We can think of it as a minus 1, a negative 1, an opposite of 1. Or you can think of it just as 1 and then take the subtraction over. So if you were doing it that way, you would just say 4 times 1, move the subtraction over. That's only dangerous because if this was negative, that doesn't work the same. So my advice, put this with the number. This is 4 times negative 1. We get negative 4, which then you can think about as subtraction. Or we could have written this 8x plus negative 4, and that would be fine.
So it's just simple to tell you the action of the number behind it.
I mean, yeah, we can look at it multiple ways. That's the problem. This could be looked at as 2x plus a negative 1. Right? And then it's like I'm doing that without really writing it out like that. That's what I'm doing. I'm saying this is really a negative 1. My 4 is actually multiplying by a negative. I'm going to get a negative result, which then I can write as subtraction. So if this is at all confusing, I would write the work purple to green to red. Okay, because that's kind of the thought process that we take. Did you see? Any questions on that one? Are we all good?
We're all good. We're good. Thou shalt be good. At least we're doing something that I actually know how to do. And you know, I have no idea. I'm fine.
Oh wait, we had
So Naya writes out the original problem. Hey guys, if you want to move on to trying 109, you can. If you're sitting here chatting, you can move on to 109. We're checking 108 right now. This will be on the test next week using the distributive property. So anticipate that you'll have probably 5 or 6 problems, and they will go over solving equations, solving inequalities, all using distributive property, combining like terms, all of that knowledge base. So, arrows. We draw the arrows so we don't forget. It's not necessary, but it's good. It's a good idea. So, did Naya do this correctly? She combined the like terms correctly? Do we agree with the answer?
Yeah.
Sweet. Now, my last one in D, I'm just going to show you guys the answer and then ask if we need to do it because we're kind of trying to hurry. Well, I'm not going to just jump straight to the answer. Our distribution would give us 3x minus 6 plus 5. Then we combine like terms and we'll get 3x minus 1 or 3x plus a negative 1. Any preguntas?
What does that mean?
Questions, except it's way cooler than questions, so it's Spanish. Preguntas means questions.
When you just said questions, I thought you would ask it if you wanted to put the questions, not answering my question.
No. Very what?
When she did arrows.
Well, because I literally just said we do arrows.
I'm sorry. At the end of your
I don't need apologies. I need changes.
At the end of your
Oh,
At the end of your first arrow, can you make another arrow?
I mean, are you saying can you do this like that?
No, like the point.
No, don't do that. That would be bad.
Mine looks wrong.
All right, so now hold up. Come with me. Join me
where are we going?
On a sea voyage.
on an adventure. So, imagine, and if you clean it back up, I've seen some people like yelling at each other. Look, you guys aren't used to paper textbooks. I used to write my book all the time. Like back when I was a student. But our books were like a decade old, so I didn't really care. They looked like trash. These are brand new. So please respect them. But if you want to like lightly write them, just erase it if you can. Like, so if you want to sketch arrows in your book while you're working through stuff, you can. Just try to erase it so you don't leave it there for next year. So we think through 2 times x, 2 times 5. We get the 2 times x, the 2 times 5. So then they're really showing their work here. They get the 2x. What else would you have? 10.
Wait, I feel like we didn't rewrite the problems with friends.
Who what?
They said,
So they're showing you everything from the distributive property.
and like rewrite the parentheses.
So that in a previous class. So they're saying the Math 7 version of doing this was with parentheses to show all the multiplication. Now our version of doing it is just do the multiplication. And we're going to get to the point where this step is not necessary and we can get right out to like our simplified version. Because as we practice, we get better at skipping these steps. So we split it. So try these on your own. Take a minute. Then we'll review the answers. I'm going to use cards in a minute. So try these on your own. By the way, one line does not mean there's only one term. It just means they just want you to write that answer. So it does not mean there's only one term. It just means write whatever you have. So, here's Koenig. What would this blank be missing? A 1, because the 3 multiplies by 2x and the 3 multiplies by x. And then what do we have simplified? Absolutely. 6x plus 3. Zach, what is this line missing? Yeah, because the first distribution is the -2 times the x, and then this line, the second distribution, -2 times the 3, and then we get, yeah, and we can put plus -6, I like that, or we can just write -2x minus 6 if we want. Either of those is the same thing. And then they make it even harder for you. They leave it all completely blank. Izzy. Cards. All right. I'm going to capture this so I can. All right. So here's where this gets really tricky, and he dries up here. We have a -3, and we have a -5, or minus a 5, or plus a net. Like, we've got a bunch of options, right? So here's my advice again. You don't have to listen, but this is going to make your life easier. Always put a plus after your first multiplication. And then use every sign you see as a sign, not an operation, as a sign. -3, -5. So this now becomes, I'm just going to write it below because I'm running out of space, negative 3 times 2x, that addition, then negative 3 times negative 5. What's negative 3 times negative 5? 15. Just 15, right? So we get, what's our answer in the end? Any questions? So I don't like that. That's not. You shouldn't make fun of that.
3 for a second. I was like,
That was just me moving fast. Any questions on that? All good? Again? All right, solve for x, and then next one while I get this captured. Now remember, we are now to the point where we need to critically think about, is it solvable? How many solutions, if it's solvable? Is there one? Is there none? Is there many? Like, is it a range of solutions? Whoa, the quadratic equation, that doesn't have any place in here. Why are you even talking about that?
I saw it on the test.
On what test? Okay, that's because it pushes you beyond where you actually are to figure out what your threshold is. Quadratic equations don't really come into play till math 2. Like high school math 2. Like, that's what I'm teaching right now in my 8th grade class that's 2 years ago. So do not think about that at all. That would never be used in this situation. We only use that when x is squared.
Every time you get a question right, it gets a little bit harder until you get it. That's how I know.
We're not using our equation map, by the
Yeah,
way.
when it's super easy, I'm like, crap, I messed that one up. Yeah. So, they asked me for problems, Mr. Hudson taught us. One time asked me for problems.
You should be solving this. I'm going to use cards to get somebody to help me. Tyler, what's the first thing you would do here?
The first thing I would do is take the 3 and multiply it by the x and multiply it by the 6.
So in that process, you draw arrows, right?
Of course we do.
Of course we draw the arrows.
Mr. Hudson taught us well.
So we get 3x plus 21. Nothing happens over here. Negative x. Negative. Hey, quit picking. I'm allowed to pick on her. You're not.
He's not a little mermaid.
I'm allowed to pick on anyone, but you're not.
He's a teacher.
It's because I'm doing it to teach you. You're doing it because you're mean.
No.
You're
I
right.
mean, I'm sorry. You get offended by me. You have some self-esteem issues.
And saying that alone is a rude statement. Like that in itself is a very rude statement. All right, Mina, what do you do next? Now, hold up. Here's the thing. There's 4 options here that are all correct. If you went a different way than Mina, that doesn't mean you're wrong. So what did you do here?
I added.
Add 3. Sure, love it, sweet. Add 3. That's 1 of 4 options.
But I don't know what to do
From
from there.
there, rewrite it. So 3x plus 24 equals negative x. Hold up. May, now where we are up here, sorry if it's different than what was on your paper, what could we do now?
Add
You want me to give you a hint? So identify your terms. We have a variable term. We have a constant term because it's just a number. It is constant. It won't change. And another variable term. When we see a variable on a side by itself, make that the variable side. So because this side has 2 different things, and this side only has variables, bring variables over here. Now, So May, do you know how I can get the 3x off of this side? If you have 3 bananas, how do you get rid of them? Eat them. Take them away, right? Take away 3x. You're with me. 24 now equals negative 4x. Now, what can we do to get the x to turn into, like, to get just one x, a positive 1x?
You can add 3x.
We cannot. Because if I add, now think about this. If I add x's over here, I gotta add x's over here. And then I'm gonna have x's on both sides, and I don't like that. Hey, can we chill? Why is x not alone right now? What's going on with it?
There's like no x's to like take away from the other side, so it's like hard to.
But like this value, right? This is not just x, right? What is that? How do you say that?
That is negative 4x.
What is holding that number with the x? What operation? Operation.
Oh, whoopsies. Multiplication.
Multiplication, right?
So I can divide 4x.
So we need to divide, but be careful. We want to keep the x close. I need all eyes up here. We've been taking a very kind of organic method to get through learning all this. All we're doing is looking at what operation needs undone. So essentially we're thinking inverse operations. This is multiply. So we know we have to divide. Then ask yourself, by what? And the by what is just the number you want to make disappear. So Ian, here, what number do we want to make disappear?
4.
No.
Negative 4.
Negative 4.
No.
Hey, if you're going to be wrong, be wrong with confidence.
I got negative 4 for one.
Please write this out. Hey, I see a lot of people talking smack to each other, but none of us were able to tell me the first time what we needed to do. So the only person that should be talking smack here, he'll be here Friday. Positive divided by negative. Negative 24 divided by 4. Negative 4. So, it scares me to tell you to do this, but work through the 2 problems on 111 with your partner so you can check and make sure you guys are doing the right thing. Try to follow the same process as your partner. So work it through together.
You're a liar.
Hey, I don't know why we're fighting over a book. You can probably see up here, otherwise you might want to go see an optometrist. I'm just like... Now remember my advice. Use every sign as a sign, not an operation. So if I were doing this, in my head, this is actually 3x plus a negative 2 times 5x plus 3. Now, you can ignore me right now if you want, but if I was solving this and I take my negative 2 and draw my arrows, I then get 3x minus 10x minus 6. If that is super confusing for you, please stick up a hand so I can come help you. Because -2 times 3. This is why I'm saying use that as a sign. Don't think of that as minus. It belongs with the 2. And if the 2 goes, the negative goes. Well, sometimes I gotta get seasoned. That's not a very good blanket. Now, as you get done, please look up here and check your answers. If we need to go over it, I'm happy to go over it. But there are like a lot of different solution processes. So it's dangerous because if I write up here a solution process, that's only one of 4. So if you have questions, stick up a hand, I'll come look at your solution process. But A and B, there's your answers up there so you can check it. Yeah.
Oh, dude.
This is 20. 14 plus 6. So this should be 20. That 8. Because you went from here over to here. Any other issues I can find in your process? If you're done with this, take the next 5 minutes to work on homework. We're not going to solve 112. I think that we could.
Oh yeah. I have
No. Positive. You can't divide by terms, but 3x minus 10.
Oh wait, you got
So add 3 and take 10 away. We're going to end up with -6. That makes sense. For those of you really wanting to play along at home,
Yes. I'm not at home. I'm at school. Yes. If you want to play along
When you are at home.
so 112, I have some people who are like, well, why didn't we do that? So 112, we're just using our basic techniques to show if we do the opposite of everything, everything flips. So essentially 112 is just kind of, I'll leave A and B answers up here. 112 is really just wanting us to show when I do the opposite of an entire quantity. And here the quantity was the opposite of negative x. So what 112 is trying to show is what's the opposite of a positive x and a negative 3. When you distribute an opposite, it's like flipping the tiles. All of them. Up to the other side, they all flip. So this would become negative x and positive 3. And that's what it shows in 112. That's it. So you got 4 minutes to work on your homework. I wanted to make sure I give you at least a couple minutes because you have 3 assignments in the span of 2 days. Now, hey, give me your attention for just a second. You're working on your homework and ignore me or give me your attention. All of the homework for the week is up. Right? It's on the board. You may not ask me questions on something we have not covered yet. It means you either need to do research on your own or skip it for the time being. Now, tomorrow's homework covers 2 lessons. But it's only 6 questions. It's like the odds. I didn't even I was looking through the questions, picking which ones I wanted to do, and it just ended up they were all odd. So it's essentially 17 through 29 odd, but skip 23 because that's a lesson problem. So 17, 19, 21, we skip 23, it's a lesson problem. 25, 27, 29. So if you want to start, now, but that's chapter 4. We're still in the CC3 textbook. Or we're going to be in the 8th grade textbook for probably the rest of January. We're going to do their chapter 4 and their chapter 5. We breeze through those. Remember, we're covering all of 7th grade and half of the 8th grade content. So we keep going back and forth. So feel free to use 8th grade textbooks here, but if you're going to take one home, you need to check with me on that. You do not have one of those books. That's a class set right now. So if you want to take one home, you got to talk with me. Otherwise, use the online book. You have access to that. Just use the online book. But I like a physical book. Like if it was me, I'd probably take a book. And my internet always sucked as a kid. My dad was a tech guy. I don't know why he didn't care to get us better internet. We had crap internet. So I would just take a book. Dude, back in the day, I don't even know how it was rated, but it was dial-up and it was slow. It was like you Google something and then you walk away to go do something, come back and look at the results. Like, click on a result, go do something, hope the page is loaded. Okay, so that little blasting pass. Have a wonderful day. Please bring me questions from your homework if you have any, so we can go over them tomorrow. Steve. Have a good day, guys.